In this lesson, we are going to be talking about resultant velocity and acceleration. By the end of the lesson, you should be able to explain what resultant velocity is and calculate it. You should also be able to explain what acceleration is and calculate it. And you should be able to analyze a distance versus time graph. What is resultant velocity? Well, this is when you combine two or more velocities. For example, if a person walks down the center of a bus while the bus is in motion, there are two velocities occurring. You've got the movement of the bus going in one direction, and then you've also got the movement of the person that is moving inside the bus. How do we calculate resultant velocity? Well, if you have the two velocities and they're going in the same direction, you're going to add them together. If those two velocities are going in opposite directions, you're going to add the positive velocity to the negative, which is the velocity that goes in the opposite direction. For the example down here, we've got 15 meters per second plus 1 meter per second equals 14 meters per second. The 15 is going to the left, the 1 is going to the right. So when we're talking about adding the positive to the negative, we're talking about the one that you start with, which in this example's case is the 15. So this is going to be our positive. And then the next one, which in this case is the 1, if it's going in the opposite direction, which in this case it is, this is going to be your negative. So then after we add those together, we've got an overall velocity of 14 meters per second to the left. So this is what we did. We did 15 plus negative 1. Or you could do 15 minus 1. That'll work as well. But what if these velocities are going in different directions? Not in the opposite direction, like we were talking about in the last one, so not like this. But what if they're going like this, or like this? So let's say Sally is windsurfing. She's moving north at 6 miles per hour, and the wind is blowing east at 3 miles per hour. Which direction would she be going, and how fast? Well, in order to figure this one out, we would have to use the Pythagorean theorem. And I'm not going to require you to know this. This was just to answer any questions if somebody wondered what would happen if it went this direction. So again, to calculate this, you would have to use the Pythagorean theorem and set it up so that you have the numbers set on the base and the side. And you're solving for the hypotenuse. Alright, let's try some practice calculating the resultant velocity. So you're walking on a moving belt in an airport. You are walking at 3 meters per hour east. The moving belt is going 8 meters per hour east. What's your resultant velocity? Well, you know they're both going in the same direction because they are both heading east. So we are just going to add these together. And this will give you 11 meters per hour east. All right, let's try another one. Carol is riding on a bus that is traveling south to the mega mall. She needs to use the washroom in the back of the bus. The bus is traveling 70 meters per hour south, and Carol is traveling 18 meters per hour north because she really has to go. What is her resultant velocity? Well, in this case, these are moving in opposite directions. One's moving north and one's moving south. Well, the bus is moving at 70 meters per hour south, and she is moving at 80 meters per hour north. With this problem, since they are moving in opposite directions, we have to add the positive to the negative. So the positive in this case is the first one we're given, which is the bus traveling 70 meters per hour south. And our negative is going to be how fast Carol is traveling, which is 18 meters per hour north. So if you add 70 plus negative 18, you should get Carol's resultant velocity to be 52 meters per hour south.